Hey everyone, it's Andrew here with Alpha Munitions, and today we're going to talk about our legacy line of reamers. So they all come standard packaging, some of the standard tooling packaging, and what you'll find inside is one of our carbide reamers. So we're going to go over some of the general characteristics of the reamer today, and then also some of the standard, if you're new to the carbide reamers or new to our reamers, some of our setup and how to run the reamers. So first I want to talk about why we even started to manufacture reamers in the first place. Reason being was we saw all these wildcats, and we had one of the first, we were the first company to come out with 6 dasher brass, and we were noticing there's a bunch of different reamer types, chamber designs, and we wanted to make sure we uniform that because small dimensions in the brass portion of the brass case portion of the chamber can really impact how the brass interacts with the chamber walls. And so we said, hey, we've got to uniform this. And so we started to make our own designs, and then we said, hey, why aren't we going to make the reamers too? So that's where we came out with our own line of reamers. One of the key features of the reamer was the tolerancing, and actually how we manufactured it to higher tolerances to make sure that when you buy one of our reamers, the next one you buy is going to be almost identical to it, and that make sure that it works correctly with brass cases and not be out of spec. All our reamers, all critical dimensions, are made within 4/10, we call them tenths in manufacturing, but 4/10,000ths of an inch. So they're incredibly accurate. This allows us to provide just seamless reamer to reamer. If you buy the reamer this year and you buy another one a couple years down the road, once it's worn out, you're going to get the same base dimensions as that first one you used. So it allows for a higher level of consistency. Next, we're going to talk about the material. We make all our manufacturing tooling out of carbide. That's true to our brass manufacturing, and we sought out some of the best carbide manufacturers, and we realized the benefits of carbide, and so we then duplicated that with our reamers. All our reamers are carbide. We do not offer high-speed tool steel reamers. So the reason we do that is for longevity. Carbide can last a long time if it's ran correctly. I'll be getting into kind of like setups and speeds and feeds in the second half of this video. But the carbide, we can tolerance this extremely tightly. It holds incredible stiffness, which is very important when chambering. And it's just, again, you can get very good longevity out of a carbide reamer. One of the key features you'll notice in our reamers is they are 6-flute reamers. If you have a really keen eye and look close and you look down the length of it, a lot of times you can see it's got a very slight helix to it. They're not perfectly straight flute reamers, they're slight helix, and there's good reason to do that. We also do offer higher helical reamers, and those are for more high production aspects. So we can do completely custom reamers than just our standard off-the-shelf ones. All our off-the-shelf reamers currently are 6-flute designs, but we are looking at, and we are in process of doing 5-flute reamers. That's because depending on the number of grooves of your barrel, you can then run a reamer that's better fit for, if it's a 4-groove, 5-groove, 6-groove barrel. And so we will be coming out and launching those 5-flute reamers shortly. Getting to the shank diameter. Our standard shanks on our off-the-shelf reamers are 7/16, and we do have a tooling flat depending on what kind of holder you're using. This is very typical within industry. We do custom shank sizes too, 1/2 inch, 12 mil, 12.5, whatever you guys need, we can do, and we'll do them with or without the tooling flats. It all comes down to what holder type you're using. If you're using some of the, free-floating tool holders, or if you're doing more of a collet system, we can account for that and make them specifically to that. The last main feature is our bushing, or bushing journal on the reamer. We designed our standard reamers for a 1/2 inch high-speed tool steel bushing. They are held on by a C-clip, which we will provide with the reamer. We make the journal 50 thou longer, so it's a 0.55 in length total journal size. That way that bushing can move slightly back and forth and allow more coolant flow to get in, or the lubricant to get in and around and under that bushing into our fluted journal area. Those are our standard features for our straight flute reamers. Like I mentioned, we can do a whole host of custom reamers. We have a line of roughing reamers coming out with chip breakers. you'll start to see those popping up on the website. And so if you need roughers, if you're doing more high volume, let us know and we'll be able to get you those as well. And then if you're a custom shop or you want some, a new custom Wildcat or some specialty reamers designed specifically for the machines you want, we can also do those. High helix, no journals. We can do pretty much anything you want. I will say though, minimum order quantity, just to account for design and setup time, is quantity of 3. So from there, we can make as many as you want, but the minimum is quantity of 3. So now I want to go in, we're going to cut the video, I'm going to redo the blackboard or the whiteboard, whatever you want to call it, chalkboard, and we're going to put on some of our standard recommendations if you're just starting with our reamers, tooling speeds and feeds depending on setup. Okay, so now I want to talk about kind of when customers call me up and ask like, hey, what should we start with? How should we start running these reamers? What do you recommend? That's what I want to go through now. And there's kind of 4 basic things I always ask or look to find out, which is the tool holding, however you're feeding the reamer in, and then generally what machine you're running, machine stiffness, because that's really going to impact both of those, and then the lubricant you plan to run or are running. So from the top, tool holding, there's multiple different ways to hold a reamer. So I would say a lot of the precision market runs more manual machines or like TLs, and they'll have free-floating tooling system that comes in with a set screw and holds the reamer and keeps it from spinning. There's other ways to hold, which is going to be one of the preferred methods where I think the industry is going to move to this, move in this direction where you have more of a call it true static holding system. These reamers will work with both types, and it's kind of just what your machine is and how hard you want to push this reamer. Tool holding definitely matters for how hard and how aggressive you are with the cut, and how stiff or how stable that reamer is going to be. Some people are running different feed systems, and so you can either run it, on a CNC where you can plug in the different settings, and that will automatically feed to 2 thou per rev, or they're going to go faster than that. Some guys will be running off of a tool post, or they can go back off of tail stock and be hand feeding off of tail stock. This really matters, especially for carbide. Carbide, naturally, you can't put a sharp edge on it. It's just inherent to the material. If you put a sharp edge on it, when it starts to cut, it will crack, it will fail in tension because carbide is extremely weak in tension in comparison to the compressive strength. So you actually radius it. So the edges actually have a slight radius on it. That's why it's not as sharp. And that's why if you've ever hand-fed carbide, you have to give it a little extra push. You got to feed it in a little harder to get it to cut. Then once it starts to cut, it cuts well. But that really also matters in the feed system. We don't want to be loading and unloading the carbide because we can't keep up with the feed system. The CNC definitely has the advantage here because whatever you plug in, it's going to run. And so if you plug in 2.5, 3 thou per rev, it's going to run that feed and push this consistently through at that feed rate. If you're hand feeding it, you're going by feel. A lot of times, some of the mistakes I've seen is that they can't keep up with the reamer or they're not applying consistent pressure for the reamer to cut. And so what that's going to do, it's going to flex that reamer. And I'm talking about this at such a small scale, but it really matters for carbide. You're going to get that torsional flexion of that reamer. And if it's loading and unloading, you're going to see premature wear of a carbide reamer. So one thing to really keep track of and make sure you're paying close attention to for people that are manually feeding is to make sure you have a constant rate and you're keeping that constant pressure behind that reamer. So it's a strong advantage for the CNC where you can just plug and go. Machine stiffness. I think this is one of the most underrated or overlooked issues within any kind of tooling or manufacturing. People think they get a Haas lathe or they get a Matthews or whatever machine it is, and they're like, oh, this is a heavy piece of equipment. It's really, really stiff. Not so much. So machine stiffness is hugely important to making sure the overall quality of the chamber and the overall quality of your machining is up to par or exceeds or is really good. I think in our industry, if you go to more like the slant bed lathes, guys that are running slant beds with collet systems, that's going to be your ultimate in stiffness for this industry. The Haas's are still pretty good, but you're running off, a lot of tools are being run off a tool post. So you got to make sure that tool post is strong, it's in place. Sometimes, everyone crashes a machine. I can't tell you how many machines I've crashed, especially in the brass manufacturing line. But make sure it's reset, make sure everything's aligned, ready to go. And that's, again, hugely important, because if you're coming in out of alignment with a carbide reamer and you're getting that flexure, that can cause problems. So machine stiffness is something that's very overlooked that I think, could be paid more close attention to. So just check that. Lastly, lubricant. Carbide typically, a more sulfur-based lubricant is better, or oil, I should say. There's a bunch of different options out there, and if you talk to every gunsmith, especially like Viper's Venom or any of the standard water-based coolants or lubricants, everyone's got their own concoction, everyone's got their own concentration rate that, this is best, that is best. So I will say sometimes some good experimentation to see what runs well for you, it matters. But having a good high pressure system that is coming from the muzzle end down through the barrel, that way as the reamer's cutting, it's building chips. The whole point of the flutes is to help evacuate chips out. And when you have a good coolant system that's pushing down and through and spraying and pressurize those flutes with fluid, it's going to take those chips and remove them out of the way. Sometimes if you don't have a good system and it's not pushing all the chips out of the way, you'll see a chip be turned into the chamber. Now this can also happen in PEX cycling. So if you're PEX cycling your reamers, a typical is probably 50 thou. I know a lot of guys doing 50 thou packs, and so they'll go in, they'll clean out, ream out 50 thou of material, they'll pull back out, give it a little dwell time in the rear. That way the coolant can come in, push all those chips out, and re-engage. Now let's say you do that, but you don't get good chip clearance, and you have a chip sitting on the cutter head. When that goes to start cutting again, that chip is stuck on the cutting edge and in between the chamber and the cutting edge. And so it's going to turn and it's going to scar, well, the reamer's not going to turn, but it's going to turn and it's going to scar up that chamber finish. So there's just, if you're having that happen, a lot of times it's because chip's getting stuck somewhere in that process. You might want to look at improved coolant flow. So if you're looking to give our reamers a try and you have some questions, we're going to do a question and answer session on our reamers. So leave a comment here with your question, or we're gonna have an Instagram post, leave the question there. We will look at them for the next couple weeks and see what comes up. We'll pick some good questions and we will reply to them and kind of hopefully answer those questions for you. So go ahead, leave us a like, leave us a comment, subscribe to our YouTube. We're gonna keep adding videos to this, and we'll come out with another video in a few weeks answering some of the common questions about our reamers. So thanks very much for listening. We'll see you next time.